Scientists are shocked by the gradual disappearance of stars in the night sky. British astronomer Royal Martin Rees warns, in less than 15 years, the appearance of most constellations will be completely changed. All these changes are mainly caused by the increasing light pollution in cities. Even if you decide to stay away from urban civilization, just to catch a glimpse of the amazing night sky, you won't really be able to see our galaxy either. And here's what's even worse. The structure of the galaxy itself distorts our understanding of the universe. This could prevent us from detecting dangers that pose an urgent threat to the planet in a timely manner. Today's video winner reveals why our week suddenly lost so many stars. What terrifying phenomena could push the Earth into total darkness? We will explore Andromeda Interstellar. When will the Milky Way be patterned in the night sky with our solar system? How our galaxy is hiding crucial information about itself and the universe. If you're brave enough to leave the city, go to a place off the beaten track, romantically enjoy the full glory of the night sky, you may feel like you own the entire universe. But what would happen if we completely wiped the Milky Way out of the night sky? Next, only the faint light from the Andromeda galaxy can break through the darkness. The galaxy is about 250 million light-years away. The billions of galaxies that make up the universe, it can only be seen through the Harvard Space Telescope or other online resources. So if we could see the Milky Way so clearly from Earth. So scientists must have calculated how many stars there were in the early 19th century. A new table published by French astronomer Jérôme Land contains 47,300 stars. This is a landmark achievement achieved by the European Space Agency with the help of the Gaia Congjin telescope in 2017. Over 100 million stars in our galaxy. Congratulations to us. We can only see at most 1% of the total number of stars in our galaxy. Astronomers estimate that number to be between 10 billion and 400 billion stars. But where do these huge discrepancies come from? This is all because for a long time, the Milky Way has been deceiving us about its true size. 19th century scientists believed that the width of our galaxy is astounding, 10,000 light-years. But in 1970, American astronomer Harosa Puri studied globular clusters in the Milky Way and found that the disk of the Milky Way is actually 10 times wider. It's like suddenly realizing that you don't live in a quiet town. They live in the middle of busy Manhattan. Precise measurements of running distances in the 20th century confirm Shapley's loneliness. But by 2015, Chinese astronomers have discovered the largest new model crossing the edge of the Milky Way, nearly 160,000 light-years in diameter. This means our galaxy is twice as wide as we thought. We don't even realize it. In 2018, Spanish astronomers discovered a star that undeniably belongs to our galaxy. They are 200,000 light-years apart. This suggests that the actual size of the Milky Way may be twice as large as previously thought. But that doesn't mean it's twice as massive. Due to the fact that astronomers cannot weigh the Milky Way directly on a celestial screen, they estimated the mass of the star by calculating how fast it rotates around the center of the galaxy at different distances. Well, as John Kepler's laws state, These speeds help astronomers estimate the mass of the entire galaxy. About 150 trillion times the mass of the Sun. But as 2,000 years of research revealed, objects in a more massive system rotate faster. Scientists have realized that the number of stars in the Milky Way galaxy may be much larger than our terrestrial population. It's estimated to be about 400 billion grams. However, subsequent more precise measurements of stellar velocities by the Gaia Observatory revealed the star is actually much smaller than expected. This resulted in a nearly 8-fold decrease in previous estimates of the Milky Way's mass, downgraded to about 200 billion solar masses. In other words, our galaxy is larger than previously thought, but also lighter than expected. This finding does not increase the estimate of the galaxy's mass. The Milky Way has not only misled us about its mass, and it prevents us from observing a large part of the universe. In 1786, British astronomers William and Hill published his comprehensive catalogue of nebulae and star clusters. Readers were surprised to find most of these objects do not appear in the galaxy's bright banded regions. Something seems to be keeping them out of the area. There was no explanation for this phenomenon at the time, and so people call it an avoidance zone. But by 1925, astronomer Edwin Hubble proved that some of the most famous nebulae in the Herschel catalog, it's actually a separate galaxy, similar to the Milky Way, reveals that the so-called avoidance region is actually the existence of the Milky Way's occlusion region. The dense disk of the Milky Way is a huge impediment to our observations of interstellar, extraterrestrial stars. That means incredible galaxies like IC 342 are hidden. And in the fireworks galaxy in Cygnus, the gas and dust clouds in the Milky Way were only discovered through the Chandra Archery Observatory. Now this goes beyond the exoplanets that you see in NASA's animation. These animations show planets outside our solar system. Although we seem to be exploring the entire universe with confidence. But actually, almost all of these worlds are located in 2 small regions on the nearest wall of the Milky Way. None of the Tianmen observes any exoplanets in the avoidance zone. It's like learning about the fauna of the entire planet from just a few creatures in your backyard. And other fascinating creatures are hidden from view. At the same time, there are a huge number of exoplanets in our galaxy. At least 100 billion, according to the latest scientific research. According to estimates in the Astrophysical Journal, there are at least 36 civilizations in our galaxy, including ourselves, so we may not see any sign of them. Simply because of the avoidance zone. Even a super advanced alien civilization from the other side of the galaxy. It could also be because of our location in the galaxy. Makes dozens of star systems completely unsolvable to us. But that's not the most fascinating thing. Back in the 1970s, scientists have realized our galaxy is cruising through space at 600 kilometers per second. Further research revealed that our Milky Way and thousands of other galaxies are just about the same speed. Attracted to a mysterious point. This is essentially the attractive force center of the powerful Laniakea supercluster, including our own Milky Way. But as scientists have discovered, this giant magnet happens to be located in the shaded region of the Milky Way galaxy. Makes direct observation extremely difficult. Astronomers had a hypothesis. Think this attractive force monster has a mass equivalent to at least 10,000 galaxies. However, Dutch and South African astronomer Ben Nakalankoen was in this area. Domain has discovered a huge galactic cluster, the Noma cluster. Its quality is far from matching this estimate. Not strong enough to generate such a strong attraction to the Milky Way. This led to a conjecture. Is there a supermassive black hole lurking out there, devouring galaxy, and waiting for an opportunity to include the Milky Way in its recipe? Although it is impossible to confirm or refute this dreadful hypothesis, scientists now tend to believe that the so-called fineness factor is actually several silver and shaded regions located at different distances. A collection of nuclear clusters, but we may need a year before we can confirm this for sure, after the Sun orbits the center of the galaxy. The core of the Milky Way and this massive magnet will become visible, but most likely no one will be able to witness him on our involuntary trip to the galaxy. Now, the solar system and all the stars are traveling through the galaxy at 220 kilometers per second. Even a revolution around the galactic center at that speed would take 225 million years. This period is known as a galactic year. August 2022. Australian guest. Hull University geologists studied 2 ancient cratons in their home country and near North America. Tectonic plate time found some surprising evidence. Although these plates are far apart, but scientists found the same strange trace in quartz opal deposits from about 320 million years ago. Points to a massive comet impact event. The power of its influence, enough to penetrate the Earth to reach Demon, transforming a large part of the Earth into a lava world. By computing the data, scientists have discovered that this killer comet must reach a speed of 70 kilometers per second. That's 3 times the rotation of the Earth. The difference between this event and the asteroid that wiped out the dinosaurs, it's like comparing farmers. Crop dusters are as different as painted airliners. However, Australian scientists in the sediment every 172 million years to find traces of something like a powerful cosmic impact. And the solar system itself should not have such strange attractive force cycles. Therefore, the researchers proposed a theory about the galactic year. Point out that the apocalyptic event on Earth is almost entirely related to the period when the solar system passed through the dense wall of the Milky Way. The site even includes the asteroid impact that wiped out the dinosaurs. This suggests that when our solar system passes through the galactic wall, increased access to massive stars, an attractive force in the Oort cloud, increasing the likelihood that an invisible killer comet will be hurled at us. Although according to the galactic cycle, we're a year away from the next big impact, but we have very little support for the exact structure of the galactic wall. Timetable interference cannot be completely ruled out. However, even the most terrifying hidden weapon in the galaxy, all the planets in the solar system are currently housed in a giant protective star Cheongsam. And the heliosphere, created by star-like particles pushed by solar peaks. Dangerous cosmic rays from deep within the Milky Way galaxy. But in May 2002, we have encountered some situations that could deprive us of this protection. Astronomers in Boston have come up with a bizarre hypothesis about this phenomenon. About 2 million years ago, it is said that our human ancestors experienced an abnormal dry spell caused by cosmic reasons. This drought was caused by frozen interstellar clouds. The cloud compresses solar-scale sunlight, very narrow hierarchy, exposing the Earth to cosmic rays. These rays have triggered dramatic climate change. The survival of ancient humans posed a serious challenge. forcing them to migrate to their in his dangerous land. Although such extreme events seem to have promoted human development. But the next time we encounter a similar situation, probably not so lucky, they risk total annihilation. Interstellar clouds are mainly composed of hydrogen gas. Its density is extremely low. There is only one clear atom per cubic centimeter. But if these clouds absorb enough cosmic dust, its density may increase to 1 million examples per cubic centimeter. It's kind of like the Earth going through a terrifying dust storm. But in this metaphor, Earth is not a fast-running protagonist like Tom Cruise. It's like a supercar being slammed by a sandcastle. This interstellar cloud could disrupt our carrying activities. But that would be the least of your worries. And here's what's even worse. He may start to swallow the upper atmosphere. May cause a significant decrease in oxygen levels, putting everyone on the surface of the Earth in a crisis of oxygen deprivation. In addition, this dense cloud cover could significantly slow down the Earth, causing its orbit to shift towards the Sun. Therefore, human beings face the danger of surviving in a suffocating desert. It is disturbing that such interstellar clouds are not far away from us. It's only about 4 light years across. It is estimated that the solar system will encounter him in 10,000 years. However, due to the lack of illumination from nearby stars, astronomers have not yet succeeded in studying its composition. We cannot predict the specific consequences of encountering them in the future. Of all the obstacles the galaxy has thrown at us, nebulae may not be the greatest danger yet. A greater danger may await us. This is not an exaggeration. In fact, the collision of the Milky Way and Andromeda was Edwin Hubble's discovery of Andromeda. It's actually a week's prelude. It heralds a terrible disaster. The stars in this galaxy appear blue. Unlike other galaxies, they look redder with red wings. Because Andromeda is approaching us. It's twice as fast as the Comet Killer, up to 110 kilometers per second. It will inevitably collide with the Milky Way. Andromeda has about 1 trillion stars. That's 10 times the size of the Milky Way. This collision would be catastrophic for us, especially considering Andromeda's competitors. M33, which has 40 billion stars, will also participate. The collision resembled a major loading accident. Yet even in the densest regions of the galaxy, the average distance between stars is also between a few hundred and a few thousand light years. So a direct collision is highly unlikely. This collision is more like a busy intersection. Stars will pass through each other without colliding directly. Eventually, gravity binds them together into one giant elliptical galaxy, leaving only fragments of the Money Galaxy. During this merger, our night sky will reveal a magnificent light show that will last for millions of years. Even with our most advanced supercomputer simulations, it is also impossible to simulate the complex process of collisions over hundreds of weeks with complete accuracy. Such cosmic events are full of uncertainty for us. Could lead to catastrophic consequences. Scientists have envisioned 3 main fates that the solar system could face after the galaxy's demise. First, there is a 50% chance the solar system will remain on the outskirts of the newly formed elliptical galaxy. In this case, the main problem we will face may be light pollution. Rather than in the traditional sense, But the light of the new galaxy will be so bright, so much so that the month, bright and even eclipsed. But unpredictable interactions of attractive forces could also pull the solar system toward the center of the new galaxy. Close to a giant black hole formed by a 2-week merger. Its mass reaches 145 million solar masses. In this case, the solar system could be subject to extreme distortions. But the probability of this happening is less than 1%. Secondly, there is a 12% chance the solar system will eject new galaxies with attractive forces, become a lonely traveler in interstellar space. In this case, we will only be able to observe a few stars in distant galaxies, experiencing almost complete cosmic loneliness. However, considering that the Sun will become a red giant in about 4 billion years, the world is human if it still exists. You must find a new home. Could be a moon of Jupiter or beyond. Entering the interstellar abyss will mean there is no turning back. Enter uncharted territory. Finally, Australia's setting interference when observing distant spiral galaxies. A huge rare inert cyan ring has been discovered. You can't see this with a normal telescope. This finding suggests that if the solar system were ejected from the Milky Way in a collision with Andromeda, we may not enter a dark apocalypse, but into a new cradle. The compressed inert hydrogen gas produced by the collision could give rise to new stars. Offer our descendants a region with thousands of new star systems to explore. In addition, as part of the elliptical interstellar system, we will be able to study the rest of the universe more freely, including the mysterious big attractor. Think about that. Earth in a few centuries. Space travel has become as commonplace as taking a taxi. Unfortunately, no matter how many holidays we have in our lifetime, we can't get to any nearby galaxies. Because the nearest star to Earth, Proxima Centauri, is 437 light-years away. If you fly on a cash rocket, it takes more than 50,000 years to get there. If you want to reach the farthest known star outside the Milky Way, Icarus, 9 billion light-years. Even traveling at the speed of light cannot cross the galaxy in a human lifetime. So NASA is working on engines that could potentially travel faster than the speed of light. But scientists continue to encounter new challenges in their efforts. In this video, we hypothetically test various engines with engineers. Try to exceed the speed of light. However, to achieve this goal, we must find a way to break through the laws of physics. But what effect would such an experiment have on the universe? How close can we get to the speed of light? In 2017, Norwegian professor Espen Gard Hauger proposed a new mathematical theory. He claimed that spacecraft built with photons can accelerate to 99.9999% the speed of light. Photons have no mass. How to become zero can only exist when moving at the speed of light. That sounds perfect. But to make the spacecraft propel with photons, we need a new type of engine that can convert light into energy. Gardner thinks. And the best way to do this is by solar sails. So we're trying to make a sail that moves with light. To bring a kilogram of matter to the speed of light requires a sail with an area of about 100,000 square meters. This provides an acceleration of about a meter per second. If our engineer weighs 70 kilograms, They had to design a square sail that would be more than 2.5 kilometers long. This is equivalent to the length of 25 football fields. And that's not including the weight of the ship itself. But there is good news. We don't have to worry about designing fuel tanks, because we have a free one. An endless source of energy, the sun. It has been burning for about 51 years, and will continue to burn for the same amount of time. Our solar sail journey may begin very slowly, but the acceleration is constant. Catch the sun. We can push this forward for years, even decades. After about 100 days, solar sails can reach speeds of up to 14,000 kilometers per hour. In 3 years, it will reach a speed of 240,000 kilometers per hour. It will take 5 years to reach Pluto, one of the farthest planets in the solar system. The concept of constant acceleration has motivated recent years. Many research teams test increasingly advanced photonic engine prototypes. In 2015, Japan's Yuzhou Aeronautical Research and Development Agency launched Chingfan-1 into orbit. Scientists set up a 32 square meter solar sail on this small moon. Within 1 month, the speed of the 3,055 kilogram spacecraft has increased by about 10 meters per second. In addition, they successfully altered its trajectory. This marked the first success of a solar sail experiment. But it also reveals its limitations. The design has very low mobility. To optimize the interaction between the photon engine and the light particles, NASA is currently developing a technology called an occulting solar sail. The occultation solar sail project has moved into a small optical mountain in the Boeing sail. To make better use of sunlight, future photon engines will not only allow us to travel within the solar system, we can go to the nearest galaxy. However, Venus will face a problem during interstellar travel, away from the sun, where there are fewer photons that can be captured. In order to deal with this problem, an international project, Breakthrough Starshot, plans to build 1,000 small solar sails weighing more than 1. These miniature sails require fewer pulses of light to accelerate. At the same time, on Earth, the researchers plan to build a laser array with a power of a few hundred watts. These laser trees will point at the miniature sails, help them accelerate in space. The destination of this journey will be Proxima Centauri, the star closest to the sun. Unfortunately, although miniature sails will accelerate to 20% of the speed of light, it will also take 30 years. However, it will be before we leave the solar system in 2030 and fly by Proxima Centauri around 2060. But let's imagine this. What would happen if our engineers succeeded in pushing a photon sail ship to 90% of the speed of light? Of course, there will be new challenges. First of all, for someone moving at such a high speed, time will be completely different. Suppose our engineers make a quick round trip to Mars. It takes about 16 minutes and 40 seconds to reach Mars and return to Earth. However, for those who remain on Earth, the journey is indeed 16 minutes and 40 seconds. But for the engineers on board, round trip only takes 8 minutes and 20 seconds. This is because at such high speeds there is a time dilation effect. Closer to the speed of light, the more pronounced this effect. In addition, for our engineers, the space in front of the ship will flatten into a blurry tunnel. In the end, it will be darkness before their eyes. The reason is that light waves can't catch up with them. Because they move at the same speed, In other words, in front of the engineer will be an endless darkness. In theory, scientists already know how to accelerate to the speed of light. But currently, photon engines cannot achieve this. To achieve the required acceleration, we need a lot of material to make the sail and gather enormous amounts of energy to power lasers to accelerate the sails. To solve this problem, we need to create a more powerful engine based on different principles. Scientists have proposed a theoretical design for such a device. So what's stopping us from making it a reality? Theoretical physicists suggest using antimatter propulsion systems for space travel. This is a rocket engine that uses antimatter to react with ordinary matter to generate energy. When these two substances interact, they generate tremendous amounts of energy. It's 300 times more powerful than fusion, 1,000 times the rate of nuclear decay, 10 billion times the normal chemical reaction. But here's the thing. Where does antimatter come from? After all, antimatter is an extremely rare and difficult substance to make. It takes an enormous amount of energy to make and store it. So engineers have been thinking about developing hybrid engines to reduce the amount of antimatter required. In 1992, the University of Pennsylvania proposed a concept called the antimatter-catalyzed micropolymerization propulsion phase. Its working principle is to launch the fuel capsule from the 238 oil knife into the reaction chamber. We bombard them with ions, then illuminate with anti-ZZ book. When anti-intoxicants interact with the contents of the capsule, some of the material will drown. The decay of hair oil 238 generates enough energy. This triggers the fusion reaction of the knife core string. This energy drives large electromagnets to heat the plasma. Then the magnetic field guides the flow of equal interest material out of the nozzle, generates thrust to move the spacecraft forward. The advantage of this system is that it requires relatively little antimatter. For example, to go to Damien, just 100 grams of antimatter. That may sound like a small number, but not so simple when shooting antimatter. The problem is that scientists use particle accelerators to create antimatter. Only tens of millions of anti-intons can be generated per minute. It sounds good, until you realized it would take tens of billions of years to make an antimatter at this rate. Have you heard that antimatter is the most expensive substance on Earth? But so, the cost of an antimatter can run into the trillions of dollars. And not only that, after making antiparticles, you need to find a way to store them. Because antimatter will drown when it comes into contact with ordinary matter, we obviously can't put it in a regular container. In this case, a special electromagnetic trap needs to be used to make up for the penning trap. These devices use magnetic fields, high vacuum and low temperature to hold antimatter. Portable traps are currently being developed. The future may allow scientists to transport antimatter to other laboratories. Suppose our engineers have enough antimatter. So how safe is that for space travel? Suppose our engineers succeed in accelerating the spacecraft beyond the speed of light, and they don't have any adverse reactions in their bodies. But don't rush to pour, because when trying to slow down, engineers could be killed by radiation. Imagine that. A photon cruises peacefully through the universe. Suddenly our antimatter ship caught up with him. The photon will stay at the leading edge of the spacecraft. When the rocket stops at its destination, all the examples that stay on the leading edge will release a huge amount of energy at the same time. enough to destroy the entire ship and crew, even the entire planet. In theory, this catastrophe could have been avoided by slowing down before reaching its destination, and gradually slow down. But even so, there will still be intense photon radiation around the spacecraft. In 2009, Dove, a physicist at the International Institute of Higher Studies in Italy, Feeney and his colleagues studied this question. They discovered that the photon heat flux towards the spacecraft's nuclear crew is equivalent to the temperature of the Big Bang, 30-second power open-ear pattern when reached. About 100 million, 142 million. A single flight at the speed of light could threaten an entire planet. And not only that, physicists also say that flying faster than light could destroy the entire universe. In 1994, Mexican physicist Miguel Acubini proposed a warp drive model. This is a theoretical mechanism for faster-than-light travel. The main idea of the warp drive is to bend the space-time around the spacecraft. Makes it not the spacecraft itself move through space. It's space moving around the ship. This means that the spacecraft does not violate the laws of physics. These laws prevent objects with mass from accelerating to the speed of light. It's actually standing still. Spatial structures can move at any speed. However, preliminary calculations suggest that it takes all the energy in the universe to create a speed cannon. In addition, scientists are concerned that this running could become unstable when entering and pushing into rapid mode. May crash with the spacecraft. But suppose our engineers succeed in building the Acro separation engine and successfully perform superluminal centrifugation and successfully adjust the speed to prevent a catastrophic stop. But there is also an almost insurmountable problem. Acubili himself admitted, his engine is essentially a time machine, because anything that allows faster-than-light travel also allows time travel. Warp engine may create closed-class time curves. This means that the spacecraft can return to the same point, but at different times. While our spacecraft was traveling, space-time around the ship will be compressed. Travel faster than light. We may enter a time tunnel that throws us into space thousands of years ago. This could have truly catastrophic consequences. The so-called butterfly effect. The movie Thunder vividly illustrates the dangers of time travel. So much so that the accidental death of a prehistoric butterfly could alter the course of evolution. Anyway, to create a hyperdrive that doesn't destroy the universe, we need to break down the fundamentals of physics. Law, but is it possible? In 1999, British engineer Roger Shelson claims he knows how to crack the laws of physics. He developed electromagnetism. This is a model rocket that doesn't emit waste. Electromagnetic drive is a hollow structure. There are powerful electromagnets inside. Scientists believe that electromagnetic radiation bounces off the inside of the rocket. Propagation from the magnet to the device cavity. When radiation builds up in the narrowest part of the structure, will generate thrust in the engine. In 2016, NASA's in-studio lab team attempted to demonstrate the feasibility of electromagnetic actuation. Scientists claim to have measured thrust. This caused a revolution in physics. However, the team led by Martin Taya, a professor at the University of Public Welfare in Dresden, Germany, is skeptical of the experimental results. Decided to try to replicate this experiment, but failed to measure any inference. In fact, there was no inference in the original studio experiment either. What NASA scientists have detected is actually a thermal effect. The sensor simply reacts to engine heat. If our engineers built a ship with this kind of engine,
he can't move at all in space.
Not to mention high-speed movement. Therefore, in the case of electromagnetic drive, scientists have failed to crack the laws of physics. But that doesn't stop them. Any space travel beyond the boundaries of the solar system will inevitably involve faster than light travel. But according to Einstein's theory of relativity, that's not possible. Our main limitation is that objects gain mass as their speed increases. Approaching the speed of light, the economy becomes infinite. And the simple answer is this. Einstein believed that the speed of light is the highest speed that can be achieved in the universe. But modern scientists have come up with ways that might bypass the laws of physics and exceed the speed of light. They propose to create a time tunnel. Let's think of space-time as a structure. This space-time structure is distorted by attractive forces. The twisting out of control forms a tunnel-like passage. Allows you to shortcut between 2 points. It's called impulse. Physicists suggest using these wormholes for interstellar travel. Although some scientists are pessimistic about this approach, it is thought that such wormholes could only have formed at the birth of the universe. But other scientists suggest looking for them near supermassive black holes. However, this choice is very dangerous. Anything entering the wormhole will accelerate to nearly the speed of light. Makes any particles inside extremely dangerous to humans. The results show that even if we could build a warp drive ship right now, we could destroy the universe. Our attempts to circumvent the laws of physics to avoid the end of the world could lead to self-destruction. So here's the problem. It's worth trying to exceed the speed of light. Step up the throttle in the car. We will speed up. The car has a top speed, but we can accelerate faster. For example, fighter jets can transcend factors. However, acceleration has its limit. No matter how hard we try, can't exceed 300,000 kilometers per second. To break through this speed barrier, we need endless energy. But unfortunately, we haven't. However, scientists have discovered uncharted territory, such as radio waves and radioactivity, so it's entirely possible that some future discovery will change everything. How many years do you think it would take scientists to invent the next light engine? Or will interstellar travel forever be just a source of inspiration for science fiction movie directors?